Hey, Michelle, how are you? You okay? I don't know if maybe I'm not hearing anything. Hold on. Yep. Okay. So let's check out the lab. Maybe Ghislaine will join us shortly. Or Jarrell. So Michelle, I sent you the Robert Half thing. When you get a chance, you can take a look at it and let me know if you're interested. So, okay.
Oh, I am. I'm just looking for references at this point because you need 3.
You can put me down as a reference.
It's just that of all the classes I've taken, there are not very many professors where I've taken at least 2 classes. And it's always like most of the professors I've only taken 1 class from. So, you know, that's why it's kind of hard to find one at the school.
You can put me down. You can also put, see if you can put down someone that you used to work with or someone you know.
Oh yeah,
maybe.
Yeah, one person I asked, turns out he's retiring next month, so he's not going to be around. So now I have to find somebody else.
They can answer the phone. They're not.
No, they're not. They're not going to be around. Yeah, that's one.
Well, maybe looked at your LinkedIn list. Maybe somebody you know you used to work with. But yeah, I'm open to that. So if you want to put me down, that's fine too. Okay, so let's talk about what we need to do today. It's not very long. I know that you have other things in other class, so let's get through the lab. Okay. So I want to focus a little bit on volatility, and of course itself is the debugging process was pretty lengthy for me. So I had to go back, redo the step, fix the step. Documentation is helpful. I think in the book, it gives you the overall like, oh, just install it like this. And it's not simple like that. So you have to do a bunch of dependencies. So in this lab, we're going to use Debian Linux. Volatility is used to assess RAM. And we are going to use the stucknet infected virtual image. So, you know, we can download the zip and unpack it. So I wrote the step for that. There are other images available online. So if you want to evaluate malware and do some practice, Volatility is great for that. It's good for driver evaluation, kernel evaluation, especially with malware. Also looking at even like port information, but very good in the area of, you know, cache, memory, and so on. And when you work with some forensic tool, I believe NKs also have the functionality with the volatility. So in your Debian, once you logged in, you can clone, and just full disclosure, we are going to use Python 2 on this because Python 3 is a little clunky, with more Volatility 3 is a little clunky with Python 3. So as it is, there's stability problems. So we want to use the 2 version. So, and that's why for Linux, we want to only run Python instead of Python 3. Okay, let me log in here so I can demo. So once you're logged in, you can clone. Okay, and then once you clone, you need to bring down some of the dependencies for the app. So let me zoom in a little bit more. Okay. So we're going to do a Git clone and HTTPS, right? So once you do the Git clone from GitHub, I already did this, so it's going to tell me it's illegal. Oh, it's illegal operation. But once you do the Git clone, what you're going to do is you are going to install a few things. Number one, you are going to get the PC regret library. And this is going to give you address a lot of the issues that you need to fix if you don't have this library. Okay. Then you are going to install this storm. This is a disassembler library for x86 and AMD. So for your Intel and AMD. And then because when we're evaluating at the low level, it needs to disassemble, and we have to, we can use this to access the bin file, some of the low level files and so on. Then you're going to install Yara, and Yara is really good for malware identification. So especially if you're working with an image that is infected, like the one we're using. So you can use Yara with Volatility once you have that installed. You should install the PyCrypto and the crypto, okay? Because I found that even if you install PyCrypto, that's only the toolkit. In some cases, it wants additional modules to be able to unpack or decrypt the hashes. So we should install crypto. Then we also need to install Pillow or Pill. This is going to be for imaging library for Python. Then we are going to install OpenPixel or PyXL, and this is for read and write in Excel in case you need to parse it. So because it's going to give you a lot of information as the output, so you can either parse it using JSON, or you can put it over to the XML or Excel. And this is the older version of Excel, so you can use OpenPyXL to parse it into Excel. Then you can install UJSON that allows you to parse it in JSON. We are not doing all of this, but these libraries are gonna help, especially with just running the API. Okay. Any questions regarding and I tested all the install for the library. It should be working just using pip. So as you go through and install these dependency, and of course you can get set up a requirement list as a requirement.txt, and then you can go through and run the install through that text file, or you can do it line by line. So I revised this over time because when I tested it earlier, there were things that were not working and there were things that were working. So I was just trying to debug it or troubleshoot it. And here we are with a bunch of additional modules and packages. All right, so next what we're gonna do is, so I'll just do this with you. The Storm 3, right? It should already met the requirement, and then you can do Yara, Python, not just regular Yara, for malware. Oh, pip and stuff. See, I'm not paying attention. There we go. Okay, and then we're gonna do pip install, and they're fairly small libraries, so it's not too much crypto. So, and some cases you want to have multiple. So we have a cryptography toolkit, and then we're also going to do a pip install crypto. And then the crypto module. Okay, so I already have that satisfied. It says that, and then we're going to do Pillow. So pip install pill. Pillow, and that's gonna give us images. So pillow is also used in like if you're doing GUI with animation, so you need to install pillow. Then next we're gonna do Excel. So pip install open. And this is recommended by the Volatility Foundation. They said that if you're using Linux, you need to bring these things in because in some cases that you need them, or if you're running a scan that you would need them, you would have them ready. JSON. So after I have UJSON, which is ultra fast JSON parsing library, once I had Git Clone the volatility package, it should be there. Now, in the book, it talks about using the actual command, right? If you use Volatility 3, if you can get the stable version to install, you can use the command, and that command basically runs the vol.py file from the repository for the package. Okay, so what we will need to do is now, once we Git clone it, it should have a directory called volatility. So we're going to do cd volatility. We're going to get into it now. And so now if we do ls, you would see that it has, you know, all the files that you clone, the tools. So I had downloaded the stucknet.vm.zip, vmem.zip. This is going to be the next step. And you want to put, you know, you can simply put the path to the actual file, but what I did was I have it downloaded inside the module directory, so that way I can just run with it. I just run the API with that, okay? So the next part is you are going to do a wget download it, cdn.andreafortuna.org, and then stucknet vmem.zip. So once you issue this command, you will be able to download this, and it doesn't take very long to do that. Okay. And since it is a zip file, we have to unzip. And so we would need to have unzip. Okay. So once you do that, you would have to download its zip file. Then you can do sudo apt get install unzip. And then that's just an application that allows us to unzip our file. Okay, so I already have the latest version there. So this tool is going to be used to unzip the vmem image. And so once you have the image, then you just scan against the image, and you should be able to use volatility to check out the image. Okay, any question? Okay, so to unzip, you just issue unzip stucknet.vmem.zip. And so after that, after you unzip, you would have this. Okay. Now volatility will also work on Windows and Mac OS. You can download it. You can install it. This zip file, you can download it via the browser as well. I think I touch on that in the lecture. Okay, so once you unzip it, now we're ready to scan it. Okay, any question? So as you look at here, when I did the ls, I do have the vol.py. This is the script we're gonna use the script to run the scan, right? Against this zip file. So when you're using the volatility command, basically that command is to use this script for the tool. Okay. Okay. So I would then be able to invoke Python and let me double check something real quick. If I have it correct. Oh, I have it backwards. Sorry. When I type this. Okay. I suspected that. Okay. So for the next part, this part right here for step 16, or even step 15, I'm sorry. You need to do a -F before the actual, oh no, I had it right. Sorry. I'm reading it backwards because it's on the next line. So that's correct. Sorry. I am thinking about that it was in reverse. Okay, so what we're going to do next is we are going to start with using the Invoking Python, and we're running volatility. So we are going to use the vol.py, and we're going to scan against the vmem image, which is the system that's infected with stucknets. And we want to obtain image information. And so if you don't know how to use this particular module, you can do a -H for help. Okay. So that's what I'm going to do next. I'm going to do Python vol.py. So we're going to run that script. And for the file, stuxnet.vmem, and we are going to get image info. And it's going to give you a bunch of stuff about failed to import for some plugins, for registry audit pool, and so on. So there are some issues with maybe the plugins is missing, right? Like for, you know, some of this area. So we might have to take a look at how, like, see, we did install this Storm 3, but it's not able to bring that in, possibly incompatibility there. Okay. All right, so it's gonna go for a little bit. You might have to wait a few minutes. Once it's done, you are going to see the end where it's going to show some information about the OS. It's going to show you a profile information, such as Windows version and also its service pack. So it's going to give you the profile information. Then it's going to show how many processor that machine has or use, and then when that image was created. Okay, so there we go. So here I have the result for, so this is where you want to start. So here we would have the profile information. So it is WinXP Service Pack 2 x86. It also have another profile information, also Service Pack 3 x86. So you can use either or. Okay, and how it got that was doing this search, right? And then it's going to give you some kernel information and also file address space information. So that basically the path where that your virtual image is located. Okay, and then this is the physical address. Processor is going to be 1. The service pack is 3. So this is why it sees this profile. The image time. So here, right, when we create image, we always want to use UTC. So the application itself support UTC. So this was created on June 3rd, 2011 at 4:31 UTC. Okay. And then that translates to the local time. So we want to first, right, in investigation, we want to document some of these things, like what type of system that we're evaluating, when it was created, and so on. Okay, so that will give you the information here. Any question? Now, the book talks about using plugins and there are various plugins. So if you do the help option, so for example, if I don't know what to use here, I can do a -H. Okay. And it's still going to go through the process, say, oh, I can't find this in crypto hash. So here, what it's going to do is going to give you some help in, it's listing all the options and other things. Okay, so you can use this to reference how you would use the command, its options, and switch. And if you zoom in, it's a little cleaner than this, but okay. Now what we're going to do is we're going to get some additional information. Oh, come on. So for 16, we're going to use info as an option. So at the end there, I just wanted to run a --info. Okay. So it tells you what kind of checks that it went through. It looks at the physical memory. And then also, it also lists, let me zoom out a little bit so it's a little better there. Okay. So there's PS tree, and the book talks about that on how to print out process list as a tree, or you can use PS list, print all running process. And that's part of the plugins. You can also view threads, and there's various things. So these are some of the, it's a lot. And so if you want to look at dynamic libraries, that will be here. There's dump and there's the list, or driver, right? Driver scan. I think we're going to do some of that later. So in the case where if it is infected, yeah, there will be a lot of plugins that you can use. So these are quite a few plugins that you can access in Volatility. Okay, and then be able to get additional information for analysis purposes. So you can just pick 2 that you would think that will be useful. And then to answer the DLL questions, you can come down to here. You can find there's DLL dump. Okay, and then there's the list. A lot of times when we work with malware, we have to look at, DLLs. We also look at dump files. Okay, like how you can extract memory map and cache files. We also use driver to look at what kind of drivers is being accessed at the low level for certain tasks based on the malware instructions, especially rootkit. Rootkit, you would see that, with the kernel and how it's using some of the DLL dynamic libraries in Windows. Okay, so that shows you how you can view some of the plugins. Okay. And then we would try Python. Let me fix this, and then we would do modules with -p. Okay. So when we do the modules with -p, we're able to obtain information for the loader data table. This is going to give you the virtual address that is specified as a physical address for kernel memory objects. So here, if you scroll up, let me expand this all the way up. So it's giving you the address information for the kernel, right? Name, the base address, and the file size. Okay. So some are executable for the kernel, and then you have a lot of the .sys files, so system file, dynamic library files, and so on. There are also search mechanism in volatility, but if we want to capture the type of, low-level files, we'll be able to do that here. Okay, so take a screenshot, and then in general, what you see as a type of files that's displayed. So you have a system file or .sys file. Some are executable, so you do have some exe at the kernel level for the system, and mostly .sys file, right? And then their base locations, so physical addresses and file location. So this is something that we can view in volatility and not as regular user or admin user on the actual OS. So we can evaluate the image and take a look at what type of files that's there, and also how it's accessed by the malware. Okay, any question? Okay, flipping back to that. All right, so we can answer the question, what type of files do you see? Next, we're going to use the mod scan command. And similar to the last one, we are going to look at the table, for the loader data table. And it's going to scan the physical memory to show hidden drivers. And when you work with malware like rootkits, that you would see that there will be loaded and unloaded drivers. So the loaded drivers would then be used at the low level by the rootkits. Okay. So we don't have, unlike the last one, you don't see there's any kind of order. So what we can do is we can do the mod scan, right, to output some information about this, but you will be able to see hidden drivers at this level. Okay, so let's change that to mod scan. So it's a little bit quicker than the last, right? It does give you some information of the same or similar, but the order is a little different. So you do have the executable here. There's some executable there. There's some dynamic library and .sys library. So in comparison, you do see the system file that's used by the drivers and their locations. But this also shows you hidden drivers compared to the last one. Okay, I think you can find one of the things with the dump up here. I just pass it. Oh, right. There's that here. There's that there. Okay. So we should answer how it would be different from the previous step. And why should we use mod scan in volatility in, oh, I don't know why I put even, in investigating a malware. When, I think I meant to put there, when investigating malware. So I think the answers is given away in this part already, right? So it also shows you loaded and unloaded drivers or hidden drivers that's used by malware. And some malware would hide the driver or disable it so that way you can't load certain things or you can't run certain things. And so we can use mod scan to unhide it or just to be able to see it. Okay, another way that we can also look at driver is to use driver scan. You saw this when you look at the helps option earlier. This is a way that we can also use the kernel or look at the driver in the kernel. Okay. And so we can simply replace mod scan with driver scan for the next step, step 19. So here it gives you some information about the driver, their physical location. Okay. So I have driver information, also the addresses and the file, similar to the other step. But in this one, this is, we would use directly with the kernel, although, right, to look at your driver. Compared to the last one gives you also hidden driver, whereas this one's just going to give you driver that's part of the kernel. Any question? So this just shows you how you can use volatility to locate things for investigation. And then next we're going to do file scan. So in the case where if the malware is hidden on a certain file or a storage, right? Sometimes you cannot open it. And using Volatility, you can use file scan to be able to locate the files. It shows the physical offset, which is your memory address, file number, and the pointer objects. And also the permissions. And you know that malware, a lot of the time, it changes the permission of the file objects. So you can take a look at the permission and compare to what it should be or what was set before it was infected. So we would go here and we would change driver scan lastly to file scan. Okay. It's definitely quicker now than it was when I tested it earlier or yesterday. So now it's going through the files, right? So the permissions is in this column. You would have the pointer information, and then the addresses is on the left and the actual path on the right. Okay, so let me go all the way up so you can see. Going into the driver now. Oh. Yeah. So here you would have the address on the left. Okay. The number of pointer, and then the access level, and then the name. And so the question asks you what kind of information is provided, right? The details in this help us understand where that malware lives or how it's affecting some of the objects in its environment. We can take a look at, the permissions, the locations, file information, and in investigation, we sometimes would have to report the details, right? So there we go. That's how you can do file scan on an image. Any question? Okay. And there's a lot more that you can do with this. Okay, you can also go and look at, their tutorial. I think they have a cookbook where you can go through and try to practice some of the exercises. And then there are also web resources so you can use too. Okay. Anything with volatility? Do you have any questions? All right, so I'm gonna now let's move it back to the home. And then we're gonna go to the logging part. Okay. So we are going to work on logging. So logging, you don't have to install anything extra. It comes with your regular Python standard library. You can use it, right? By just either setting up the script, run the script. So the basic config method, the book talks about this, is to configure how your loggers can behave. You need to create a logger for each of the module, and you can also configure the file, right? You can use basic config to do that. Most application, such as Django, would automatically have file-based or dictionary-based logging configuration. Okay. Now, in the exercise that we're going to be doing, we are going to create a log, right? And we are going to use the file handler for file.log. You can set it up where you would create the object, right? Here we would create multiple objects to be able to show a certain message under the event that occurs. So the book talks about using formatter, and formatter is a way that we can output the message in a particular format. You can do logs for login or failed or success login. In the case of Windows, we would see that, that will be part of the audit logs. So in the script here, at the beginning, after we import logging, we create logger, right? So that's where you would start. You would start with creating an object. Now, we're not using basic config here, but we're using get logger, and for the parameter, we're gonna pass the namespace. Now, each of the logger would need handlers, and so we would have C handler. This is another object. Okay, we're gonna use the stream handler. We're going to use F handler. That's going to be the file handler. That's going to generate our file, that log file. And then in order to set up the messaging, like warning, info, critical, and so on, we need to use the handler and be able to do the set level. Okay. So here we would set it for warning, and you can do the same thing with error or critical or so on. Okay. Now, after we define the handler, then we're gonna create the formatters. Okay. And so here in this case, we're using two, C format and F format. And that uses the formatter class. This is going to allow you to show like timestamp, a certain warning message or message, right? So after I define the formats or the formatter, I would use it as arguments in the set formatter. So lastly, we are going to add the handlers. Okay. And we defined the handler already in the prior section. So we're going to pass that here. And so there are two. So we're going to do a C handler and then the F handler for file. And for the warning and the error, since we only did two, right, we want to output a certain message. This is a warning or this is an error. So when you look at this code, first you create a logger, then you define your handler. Once you have your handler, you would use it to set level for warning or error, critical, different categories of your logs. And then you would set up the formatters on how that's going to be outputting, right? How it's going to look, what kind of information it should contain. So once you define your formatter, then you would set format. And then coming back to the beginning, you had defined logger. So now once you have the handlers and the handler being formatted, you would then add the handler to the logger. Okay. And then output. Okay, so let's come here. Let me clear this real quick. Okay, so I'm going to go ahead and nano into my test log. I use test log 1.py, but I had written down for test log. And so this is the script that we have. Okay. And we talked about this just now. After that, I would save and then I simply run it. So on this one, it is using Python 3. So here, let me see what do we need to tie this log to an event, like an event handler in JavaScript. Yes, so you can do that. I think the intention is that you would tie the log to an application or a certain part of that application. Yes. Because otherwise it's only going to print two things because it's not right. When you look at the file, it's not going to have much. Python test log Python 3 test log 1.py. Yeah, see, it's only going to print two things because that's what you had. It's going to show warning and error and so on. So you can tie it to like a login event. You can tie it to certain anomalies and so on. So looking back here, when you define your handler, right, and how you want to use your handler, you can specify that there. So now I'm going to do an ls real quick. So it creates the file.log here. Okay. After we ran that script, it created the file.log. And so you can generate the log. I think, there are a few examples if you look at the book on how, some example would actually, force you to open a file and then write the log to the file. But since you're using the logging module, you would have the handler to be able to generate that. Here, the file handler. Okay. And then to add the content to the file, you have the stream handler for the content that's going to go inside the log file. So as I complete that, I can take a screen capture. You can explain how logging module is used in the script to generate logs, right? You can talk about different types of handlers and how we create the handler and be able to implement that with the formatter or add the handler after we set the format, and then how it's going to output. So for the project, I did require that you have to have some form of logs, and I would let you choose on what things you want to log, for the web server. Okay, we did walk through on how we enable services so you can log, certain things, communications, or certain type of error in the case of connectivity. If, for example, if the servers, respond to the request, right, a certain way, or if it's not able to give you a certain status code in connection, it's going to generate, the connection error, and then so you can take that and put it into a log and be able to parse it for later use, right? So with that, we can evaluate the performance and the availability for it, or even when it's redirecting or, wrongly redirecting. So with web server, it's fairly easy because you can apply it to a certain status code condition and be able to examine the log based on the status code and so on. So I'll leave it up to you on what you think that will be best. If it is your web server, how would you want to log and what kind of information should be on your log? Okay. So, any questions? And you can also, I think in the chapter, it touches on window registry. Since the stucknets, the vmem image is a Windows image, you can also see how if you can implement, scripts for reading register or the registry records. So you can go in and look at the entry and see if there's any modification and so on. So there's a section in the chapter that talks about that, right? Any question? Okay. So you should be okay here. And then we can also practice. So in the units, I have the notes open here. You would see something similar, right? The author actually implemented the debug, so you can definitely do the debug with your logs. And then if you need to manage the configuration file, so you can do file config and then you can specify. Okay. So there's some other example that's included. Let me also see here. At their code also. Yeah, so the example provided, there was an example that you can parse it into JSON like this, right? So here it's only using regular JSON, so you can have JSON and then the path. This one's using the OS module and the logging module with the config. Okay, so you can also take a look at this. And it uses the basic config like we talked about there. Okay, so here it shows you the timestamp, the root, debug info, and then info for the handlers. So this is another way that you can also use logging, but with this we are also implementing other modules. Okay. For configuration and parse it into JSON. Okay, Any questions? All right, so I'm gonna go ahead and stop recording.